Is going to be about the assembly language and how to output hello world using the assembly language. So as you can see here, I've already written my code. Um, there are many ways on how to output hello world in your assembler, but I'm going to use this specific method which I already wrote here in the editor. So I'm going to explain this code line by line, and hopefully you guys could keep up. So here we go. So the first line, in line one we have data segment. So what this code does is we use the keyword segment to declare a segment, a partition in or starting point of the data in the program. So we assign data to be its name, the name of the segment. So basically it's a declaration of a segment with data as its name. So next line is we wrote message db hello world $, enclosed with double quotation marks. So this we we declared another variable here, another with a new data type that we use is define byte. So it's what you use when you assign strings to a variable. And so yeah, and when we write strings in hello world, we end them with a $, so that the compiler knows when the message ends, when the string message ends. So next line we have is ends. So it's a keyword to end the data segment. So basically that's, yeah, to end the data segment. So next line we declare another segment which we named code. So and in line 6 we wrote assume ds colon data then cs colon code. So what this actually means is that in this assembly language programming there are different registers present for different purpose. So we have to assume data is the name given to data segment register and code is the name given to the code segment. So yeah, so in this we assume that for ds contains the data segment and that cs contains the code segment. So yun, so we just assigned ds and cs to data segment and code segment respectively. So now we move on to the next line, and here we officially start the main body of the program. So of course we use the keyword start here, as you can see. So that basically means this is where the program or the program execution would start here. So in the next line we use the keywords move and the registers AX. So in this two lines works as they sort of work together. So due to the restrictions of the move command, we first assign this segment data to AX, which is a register. This is the first register in the list of registers that is used in the assembler, so or in assembly. So due to the restrictions of the move command, so we assign data to AX first, then we move AX, the value of AX, which is data, which is this, which is hello world, and we move it to DS, which is, yeah. This part is also called initialization of data segment, and it is important so that the data elements or variables in the data segment are made accessible, so that you could use it later on. So yeah, so that's basically what move is. So now we move to the next lines. Now these three lines, 11, 12, and 13, function together as well. So the first line of this block is LEADX message. So what this does is, actually LEA stands for load effective address, which is used to assign addresses of variables to the DX register. So we first, in our data segment, we declared message in our data segment here above in line 2. So whatever was the content of this variable message, which is hello world, we are going to assign it to DX. So every time we call DX, the hello world message will be loaded. So yun. So in the next line, move AH9. So and interrupt 21H. So first we assign the value 9 in AH. So we will use this in our when we call the interrupt, because the value 9 the value 9 means print string. So first let's go back to line 11 here. So first we assigned message to DX, and we assigned 9 to AH, which is the register for our interrupt values. So at the moment we called the interrupt 21H, which has the assigned value 9. So whatever was the value of your register DX will be outputted. So as we all know, the value would be hello world, and in this line, this is where hello world would be printed. And so yeah, these next two lines now, move H comma 4CH and in 21H, is actually your closing statement. So standard input and output related interrupts are found in 21H. So this is, yeah, which is also called the DOS interrupt. So yeah, so the value for same here in our previous block code, we assigned 9 to AH. So here we assign 4CH to the register AH. This value is for exiting the code, for terminating the code, for returning the command to the operating system. So once after we assigned 4CH to AH, we call the interrupt function again, and this time the program terminates, and we return the control to the operating system. So we type ends here. So that's where our code ends, and end start, and which stands for, it is a label used to show the ending of the code which is written in the code segment. So whatever was here, so it ends in here. So let's run the program to check. So instead of using run, I'm going to use single step, so you guys could see how the whole program would flow. So first it moves whatever was in DX and AX, as you can see here. Then DX gets the value. Then we assign AH with 9, the value 9. So and then we call the interrupt 21H. So returns to the BIOS. Then as you can see, during this line, during the interrupt 21H, this is where hello world is going to be outputted. So as you can see here in our emulator screen. So now we proceed to the next step, which is assigning 4CH to our AH register and calling the interrupt. And as you can see, it returns the control to the operating system. So basically it ends the program, this line here. So that is video. Thanks for watching.